All right, so let's talk about how to do a one mean t test. T as in tiger. So we're going to use the phantoms process again, and it's going to be very, very similar. And I'm just going to go through and highlight for you where the changes are. So the P is still the claim that we're going to test. So such as the mean battery life is less than 300 hours. We still have the same hypotheses, a null hypothesis and an alternative hypothesis. They both have a mu for them because we're still talking about one mean. And the null hypothesis is mu equals a number. And the alternative is going to use that same number, and it'll use the less than, greater than, or not equal to. So we'll still have the left, right, and two-tail. Our assumptions, so we still have this simple random sample that allows us to do our statistical inference, either a normal population or a large enough sample, so n equals 30 or more would be the large, and that allows us to use the central limit theorem. And then here's the change. So again, sigma is unknown. So no sigma, no population standard deviation. Instead, we're going to use the sample standard deviation, which is represented with the letter S. Okay, you can usually get that just from going to your data set. The name of the test, this is a t-test or a one-mean t-test. All right, when we calculate our test statistic, instead of it being Z as in zebra equals something, it'll be T as in tiger equals something. And then we did swap out that sigma for an S, but otherwise it remains the same. Okay, your p-value, so we're using a slightly different formula for that p-value, but that's already been programmed into your spreadsheet, into the calculator on the Excel spreadsheet, so that's ready to go. And then make a decision, the same things still apply here. So if p is less than alpha, we're going to reject the null. And if p is greater than or equal to alpha, so in other words, if p is not less than alpha, then we do not reject the null. And then you're going to state your conclusion. So with a p-value, you'll list your p-value, you'll give the significance level, and then either we do or do not have sufficient evidence to conclude whatever it is that we're looking into. So this should look really, really, really familiar. There's just a couple of tiny changes here. The biggest one being that your population standard deviation is unknown. So no sigma. And so instead you need to use your sample standard deviation S, which you can find from your data set. And that's what tells us that we're using T as in tiger for our distribution instead of Z as in zebra. All right, so let's look at the problem number 3. So we're going to practice writing our hypotheses again. So we know that we have a null hypothesis and an alternative hypothesis. And so this is how you tell me this is your null hypothesis and this is your alternative hypothesis. So a recent survey of college campuses across Ontario claims that students spend an average of 2.7 hours a day using their cell phones. A random sample of 35 Durham College students showed an average use of 2.9 hours a day with a standard deviation of 0.4. Do these students use their cell phones more than the typical Ontario college student? Okay, so my null hypothesis is mu is equal to 2.7. Okay, so this is the hypothesis itself, mu equals 2.7. And then my alternative hypothesis, so we're interested in whether they use their phones more. So it'll be mu is greater than 2.7, which gives me a right tail test. All right, and come back to the next video. We'll take a look at how to work through that process of phantoms on a t-test.